The topic is solving initial value problems by Laplace transform. So let's do this example. Solve the initial value problem, second derivative of y plus 9y equal e to the t, y of 0 equals 0, y prime of 0 is 0. So again, when we use Laplace transform, the first thing we do, we take a Laplace of the left side, and it's equal to Laplace of the right side. Right? Now, using the linearity, this means that Laplace of second derivative of y plus 9 Laplace of y is equal Laplace of e to the t. Now, I don't know if this will be enough. So let's move on up here. Now, Laplace of second derivative, we're going to use number 3. So that would be s squared y of s, big Y of s, minus s, little y of 0, minus y prime of 0. That's just L of second derivative of y by definition, plus 9. Laplace of y is just using number 1, which is y of s. And this is equal Laplace of e to the t. We're going to use this column from the Laplace transform table. So it's equal 1 over s minus a. See, my a happens to be 1, right? So 1 over s minus 1. Now, next thing, we always plug in y of 0 and y prime of 0, which are right here, initial conditions. So s squared y of s minus s, y of 0 is 0, minus y prime of 0 is 0, plus 9y of s is equal 1 over s minus 1. Now, cancel the zeros, you'll have s squared y of s plus 9y of s is equal 1 over s minus 1. Our goal again is to find y of s, so we can do Laplace transform, the inverse Laplace transform. So y, a factor y of s, if you factor it, you get s squared plus 9, which is equal 1 over s minus 1. So y of s is equal, if you divide, you'll go straight to the bottom. Right, now my little y of t is equal to Laplace inverse of 1 over s minus 1 times s squared plus 9. Now, before we can use the table of Laplace inverse, we have to use partial derivatives. So let me do it here. So 1 over s minus 1 times s squared plus 9. Since s squared plus 9 cannot be factored into a linear equation because it doesn't have real zeros, then we have to rewrite this as a over s minus 1 plus bs plus c over s squared plus 9. And then we need to find a, b, and c. So if we want to do that, we need the same common denominator. Common denominator would be s minus 1 times s squared plus 9. So I multiply s squared plus 9, the top and the bottom. And then for this one, it's missing s minus 1. So I multiply s minus 1, the top and the bottom. Now, the denominators are the same. So this means that a times s squared plus 9 plus bs plus c times s minus 1 is equal 1. So all we need to do is distribute. So this will be as squared plus 9a, and then FOIL, that would be bs squared minus bs plus cs minus c is equal 1. Now of course we need to factor the terms of s squared first. This is going to give me a plus b factor of s squared, and then the terms that has s minus b plus c, or c minus b factor of s, and then the constants are 9a minus c plus 9a minus c is equal 1. But remember, 1 is the same thing as 0s squared plus 0s plus 1. So a plus b is 0, c minus b is 0, and this is 1. So system of equation is a plus b is 0, c minus b is 0, 9a minus c is 1. So how do we factor this one? I mean, if you notice, the easiest way, use the second one, solve for the c. See, look at this. If c is equal b, and then plug in the b here, and use the first equation. See, the first equation says a plus b is 0. If you plug a b in here, you get 9a minus b is equal 1. Now this is system of equation, that's easy. Just add, you get 10a is equal 1, which means a is equal 1 over 10. So we got the a first. Now how do we find the b? You can tell the b is equal c. So what else? Once we have a, find the b using this one. So b is equal minus a, which is equal negative 1 over 10. So my b is negative 1 over 10. So what about c? c is equal b. You can see it here. So c is equal b, which is negative 1 over 10. Now all we do is just plug it back in here, right? So Laplace, let me do it in one shot. Laplace inverse of 1 over s minus 1 s squared plus 9 is equal Laplace inverse. Remember, it's a over s minus 1. A happens to be 1 over 10 over s minus 1 plus bs. b is negative 1 over 10 s plus c. c is minus 1 over 10. All of that over s squared plus 9. Now what we can do here, we can even take off 1 over 10 outside. So this is going to be equal, use linearity, Laplace inverse. Let's take 1 over 10 outside. 1 over 10 Laplace inverse of 1 over s minus 1, right, plus 1, well, minus actually. Let me do it in 2 steps. Laplace inverse of negative 1 over 10s over s squared plus 9 plus Laplace inverse negative 1 over 10 over s squared plus 9. Now this is equal 1 over 10 Laplace inverse of 1 over s minus 1. I'm going to take negative 1 over 10 outside. Then I get Laplace inverse of s, and I'm going to write 9 as 3s squared, because I'm looking already at this column of that row, right? Plus, minus, I'm going to take 1 over 10 outside. And then Laplace inverse of 1 over s squared. Same thing here, I'm going to write 3 squared, because I'm looking at this column. But if you look at sine of kt, when you look at this, I'm missing the k, so what I'm missing here 3. So what I'll do, I multiply by 3 and divide by 3. I can do that. And now what about the other one? The other one is fine. So now looking at the tables, so this is equal 1 over 10. Laplace inverse of 1 over s minus 1, I'm using the first row. So it's e 1t, which is t, minus 1 over 10. I'm using the third row, s over s squared plus k squared will be cosine. So this is cosine of kt. My k is 3. So cosine of 3t, and then minus 1 over 30. And then this is going to be sine, looking at number 2, sine of kt. K is 3. So sine of 3t. So this is my y of t. So y of t is equal this, y of t. So the solution is right here. And that's it for